It's time to warm up. And so start here. This is our theta. This is a 60-degree angle, and it says here that the hypotenuse is 1. So what we remember about these is that this shorter length across from the 30-degree angle is going to be half of the hypotenuse. Since this is 1, that's going to be 1/2. This one is whatever this side is times by rad 3. So rad 3 times 1/2 is going to be rad 3 over 2, which means that when we want to find the sine of theta, this time theta is defined here as this angle. It's going to be opposite over hypotenuse. So that's going to be 1/2 because the hypotenuse is 1. For cosine, it's adjacent over hypotenuse. So it's going to be rad 3 over 2 divided by 1. The tangent, well, that is opposite over adjacent. So let's do that work. 1/2 over rad 3 over 2. As you can see, this is a very messy looking fraction. So if I capture it, it's really 1/2 divided by rad 3 over 2. It's a better way to see it. And that's going to give me 1/2 multiplied by the reciprocal 2 over rad 3. What we're seeing here is that these two are going to cancel, and I get 1 over rad 3. If we were in geometry, we might leave this, but because there's the rad 3 here, we want to multiply top and bottom by rad 3 to get our rationalized answer. That's going to give us rad 3 over rad 3 times rad 3 would be rad 9, and the square root of 9 is 3. So that means that this is our final answer, rad 3 over 3. For cosecant of theta, let's see, cosecant starts with the C. It's the reciprocal of sine. So I'm going to take this and flip it upside down. That will just give me 2 flipped upside down. So that's going to be 2 over rad 3. Just like we did over here, we're going to need to multiply by rad 3 over rad 3. That gives us 2 rad 3 over 3. The cotangent is this in its reciprocal form, but we have to remember that this is really this one here before we multiplied by 1. And so if I take this and I do the reciprocal, it's going to just be rad 3. And so now we have solved for theta. These are all for 30 degrees. This is our other special right triangle that we need to be familiar with. And what we see here is that these sides are equal, indicating that these angles are equal. This is an isosceles right triangle. And so each angle measure here is 45 degrees. Because of that, we know that it's x squared plus x squared is equal to 1 squared using the Pythagorean theorem. Where these sides are both unknown as x. So I have 1x squared plus 1x squared, that's giving me 2x squared is equal to 1. Dividing by 2, I'm getting x squared equals 1/2, and then I take the square root. When I take the square root of this fraction, I'm taking the square root of the top and the square root of the bottom. The square root of 1 is just 1. So this gives me 1 over rad 2. But just like we saw over here with tangent, with the rad 3 in the denominator, we're going to need to multiply to rationalize this. So I multiply by rad 2 over rad 2, which gives me my final answer of rad 2 over 2, because rad 2 times rad 2 is rad 4, and the square root of 4 is 2. So the sine is going to be opposite over hypotenuse, and the opposite is rad 2 over 2. Dividing that by 1, we're left with just this number. The cosine is adjacent over hypotenuse, so that's going to be the same thing because they're the same amount. This means that our tangent is opposite divided by adjacent, and since those are exactly the same, the answer is going to be 1. Cosecant of theta, that's the reciprocal of sine. Sine, remember that these were our primaries, and then this was rationalized. So I want to go back to this to find the reciprocal. The reciprocal would now be rad 2. Is that true for secant, which is the reciprocal of cosine? Yes, it is. And then tan being 1, or tangent, means that cotangent, the reciprocal of 1, is 1. So this was super fun. This was a great warm-up. The next thing you need to do is draw a blank x and y axes. You'll notice that I am intentionally labeling the quadrants. Remember that this one is positive in terms of our signs, x and y. 2, the x values are negative and the y values are positive. I can imagine hair might have the coordinate, how many for x? 1 and 0 for y. Same distance on another side, I could have a coordinate right here, and right here. 0 for x, 1 for y. -1 for x, and 0 for y. Same 0 for x, but this time we're -1 for y. We're showing here that the radius is always 1, which is why this is going to be the beginning of what we're going to call the unit circle. The next thing that I can do is now I can imagine, okay, if this is 1 whole, where's about half? I would say half is about here. And half is about there. It's half, imagine. So let's see, this is half. I'm going to go up to the circle. And now you can see I've drawn a triangle. And here again, the radius is 1/2 here. And who does that relate to? That relates to my warm-up. So if this side is 1/2, it's this rotated triangle. The height here is going to be rad 3 over 2. So as I look at this, I want to find the coordinate here, x, comma, y. It's blue dot here. And I can see, oh, the x is this distance here, and that was 1/2. what is the height? Oh, the height is rad 3 over 2. If this is half here, I can also go down, this is also half. This is half here. I could imagine this angle here. Again, it's a right angle. This is half. So now this is rad 3 over 2. And I could equally draw this triangle. I called it a rectangle. This is half, and this is rad 3 over 2. And what about this one? Well, you can see that my triangle is 60 degrees. Here I can find the ordered pairs in quadrant 4. So we already know that the x value is half. We're in the positive x. And this time we see that the y value was rad 3 over 2, but because we're below the y-axis, it's going to be negative rad 3 over 2. Here, this is half, but again, we're going in the negative direction for both x's, so this is actually negative half. This rad 3 over 2 is negative, but this rad 3 over 2 is positive because it's above the y-axis. So this one's rad 3 over 2. And this is the negative 1/2. This one is negative 1/2. And this one is, oh, again, negative rad 3 over 2. What we're seeing here is that when we have the hypotenuse of 1, which all of these triangles share, we have a central angle that's like 60. It's like in the same family, and what happens is we get the exact same coordinate, 1/2 and rad 3 over 2, 1/2 and rad 3 over 2, 1/2 and rad 3 over 2. But what changes? This one was positive, positive. This one is negative, positive. This one is negative, negative. And this one is positive, negative. And that's because they're in the different quadrants. What we're seeing here is the beginning of what we're going to call the unit circle. In regard, if we consider this, x is going to be 0 degrees, right? That's the flat line. And then this makes 60 degrees going this way. We're going to go counterclockwise. Here's the right angle. So this would be 90 degrees. And then we go another 90 degrees, and 90 plus 90 is 180. Then we can go another 90 degrees to make 9 times 3, 270 degrees. And then 90 times 4 is going to be 360 degrees. So we know that this is 60, this is 30 to make 90. So this must also be 30. So 90 plus 30. This is 180 degrees. And then from here you can see that we need to go 60 more. 80 plus 60, let's find out. At the zeros, 4, carry the 1. This is going to be the angle measure of 240 degrees. We know that this is 30 to make 270. Oh, that adds up. And then we need 30 more to get to this 270 plus 30. Back on a blank one. And let's quickly label what we know. This is 1, 0. So who's going to be most closely related to this special triangle is going to be our 30-degree angle measure. So now, instead of imagining a 60-degree angle like this, I'm going to have to imagine this shape. So now you can see that the height is going to be half. Now I'm going here and here. Hopefully that's visually half. And I'll have these at the same height. These are all showing the interior angle of 30 degrees. 30 degrees. And this one is 360 minus 30. What do we know about this one? Well, this time we know that the height is 1/2. Meaning that the longer side is not the 1/2. It's the friend, rad 3/2. Let's go and put this into an ordered pair. X is going to be the longer side. X is rad 3/2. The Y value is the shorter side, 1/2. So this, once we get this green coordinate, these are all green coordinates together. It's going to be the exact same numbers. Rad 3/2 and 1/2. Rad 3/2 and 1/2. Rad 3/2 and 1/2. What do we need to change? Oh, this is negative X values. These are both negative. Now X is negative, but X is positive, but the Y is negative. And so let's figure out, this is 30 degrees. Here's 60, 90, 120. Oh, so we're counting by 30s. That means that this is 150. 180. 180 plus 30. This one is 210 degrees. Here's 240, 270, 300, 330. So when we count by 30s, this is pretty much the clock, right? Here's your 12 o'clock. And who comes after 12 o'clock? Oh, the clock goes clockwise. You're noticing that this goes counterclockwise. So,
oh no, you guys, the video got cut out, but looking here in yellow, I formed these diagonals going exactly across. So you can imagine that this is, right, a perfect 90-degree angle right here, meaning each one of these is 45, 45, 45, 45, 45, 45. Like you're making a pizza. I always make 8 pieces of pizza. And when it's 45 degrees, that means that we're looking at each side being rad 2 over rad 2. So you'll notice in yellow we have rad 2 as the X and the Y coordinate, which are 45 degrees. Then 45 plus 45, 90. 90 plus 45 is 135. I guess 135 plus 45 is 180. 180 plus 45 is 225. 225 plus 45 is 270. And then 270 plus 45 is 315. 315 plus 45 is 360. And so that's now the full unit circle. You can see that it's made of these small triangles that are either a 30, 60, 90, a 45, 45, 90, or in these cases, a 60, 30, 90. What we like about these is that when we're doing this, the coordinate is actually going to be the answer to either the sine or the cosine. So the sine is the Y value, because when we're looking at this angle that's made, so we can imagine this 45, this is the triangle here, and the X value is adjacent and the Y value is opposite. And since sine is the opposite over hypotenuse, with the hypotenuse of 1, it gives us just the numerator. So that's pretty cool, and that's why we really like this unit circle. And we're going to practice seeing, can you fill in your own unit circle with the degrees, and can you use it meaning use these coordinates, x and y, to find the cosine and sine. Let's give it a try.